Hello, I'm Dan Alford. Welcome to the ARC Specialties Weld of the Week. On this week's Weld of the Week, we're going to look at an interesting gas tungsten arc welding application. We're welding a nitrogen strengthened stainless steel. This is an odd material. It's 0.4% nitrogen, and that's a huge volume when you understand that it's by weight. When you're welding these nitrogen strengthened steels, you have to maintain a very low heat input. Otherwise, you'll lose the nitrogen from the part, and nitrogen is a critical austenite stabilizer in these alloys. So what we'll do here, in addition to minimizing heat input, is we'll water quench between passes and then air knife dry. And from the video, you'll observe that we're using cold wire rather than hot wire. You can tell because we're feeding the wire in from the front edge of the puddle rather than the back. I'm not convinced this actually reduced heat input. This was a customer request. This was a full penetration weld, but we agreed to tackle it because it had a J-prep. J-prep greatly simplifies full pin welding. And the other trick that we applied to this is something we learned years ago when we were welding NASCAR cams. NASCAR rules limit cam lift, but they don't limit how far you float the valves. So when these engines are running over 4,000 RPM, you're actually floating the valves and getting additional lift. It all is well and good until the tappet lands back on the cam, and when it does, it better land on something hard and wear resistant. This is why we're applying a welding coating to all these camshafts. One of the challenges of welding these NASCAR cams was the fact that they had already carburized these shafts before they gave them to us to weld. And the edges of the weld are only about 40 thousandths thick, very easy to melt. So that's when we developed synchronized pulsing. And on the camshafts, we actually reduced current at the edges to avoid melting those sides. In the video that you're going to see today, we flipped this backwards and we're increasing the current on the edge to ensure good sidewall fusion. This is a great demonstration of the ARC Specialties control philosophy. We treat the welders as big amplifiers. We control the current based upon either pulse time or, in this case, oscillation position. By allowing us to control everything from a single computer, we can synchronize pulse and, in this case, ensure good sidewall fusion. At the end of this weld, you also see the servo wire retract at the end of the weld. This is critical to avoid wire sticking at the end of each weld, and then we're slowly ramping current down to avoid any crater cracking. Here's a snapshot of the control panel. Everything is controlled fully automatically, all the way from the root through the quench and air dry, all the way to the cap pass. We even include back purge as an automatic function in this system. All the videos you saw today was shot with a Xiris vision system. We found that a vision system is critical not only for process development, but for ongoing quality assurance on these fully automatic machines. We look forward to posting new episodes of the ARC Specialties Weld of the Week. If you're one of the thousands of operators of ARC Specialties equipment around the world and you have a weld that you would like to showcase, please contact us. At ARC Specialties, we thrive on problems. Send us yours.